Okay, so Tech Tuesday number 7. Thank you for coming. I'm going to talk about protocol patents. That's not patents about rituals with royalty, but here's an example. So you have an invention and the right protocol to use when you're applying a treatment. So as an addition to your existing IP portfolio, that's nice. But what happens if that's the only invention you have? So as a guy who does mostly devices, I think that developing a protocol is hard work, just like developing a device. But when you're done, you have a lot less tangible things to show when you finish.
Mhm.
So I'd like to distinguish 3 types of protocols, and of course there's more. The first one is treatment, which is how do you apply treatment so that the treatment works, avoid side effects, and so on. The second one is diagnosis. Again, it's a sequence of acts that you do in order to help diagnose a patient. And the last one is completely different. It's communication. So this is a ritual. Okay, we're talking now, either you're watching a recording or watching me live. It's using lots of communication protocols, which say how one computer will talk to another computer. These protocols, in a sense, are rather arbitrary, but they're important, and definitely some of them are covered by patents. Now, what I'm not going to talk about is what we could call parameter inventions. Parameter inventions are simpler than protocol inventions. All they say is, here's a number. When you hit the nail with a hammer, use between 20 and 40 newtons. So I'm not going to talk about them. These are even more problematic to protect. I'm going to talk about protocols, which are always more complex. It's usually some sort of sequence of acts. And here's a poster child for protocols. Electrical stimulation sequences. So you call them electroceuticals. And the way to look at it is some sort of interaction, not all of them, but most of them, some sort of an interaction between a physiological process and a forcing signal. The easiest example is a pacemaker. So when you have a pacemaker, it applies electrical stimulation to the heart with a certain logic, and that's where the protocol comes in, and a certain timing and certain parameters in order to protect the person against heart failure or for other reasons. Now, the problem with electrical stimulation sequences is it's a very easy to reverse engineer. Somebody can take your machine and simply measure what it's doing. It's also very easy to create variants. Oh, let's make this schedule a little bit longer. Let's change the frequency. Let's change the logic a little bit. Testing, in other words, if your competitor wants to test a new protocol, it's not as easy as early stage pharma, meaning drugs can often be tested in an early stage in cell cultures, and electrical stimulation sequences usually cannot. But it's way easier than late stage pharma, meaning if I now want to test a new protocol variant on 400 patients, it is much easier to do than to test a new drug variant on 400 patients. Now, if you really work hard at developing these electrical stimulation sequences, then the protocol will be quite clever. It will have fail-safe behavior. It will have significant advantage over alternatives. It will be matched with the way you select your patients. And if you're lucky, you can also know all of these details. And what I call exploration results, meaning protocols we decided not to use and why we decided not to use them, you might want to protect using trade secrets, and in some cases, they're even going to be know-how, which is difficult to write down. In any case, the law does not require you to give competition an explanation why one protocol is good and one protocol is not. Unfortunately, what is just as common is somebody develops a protocol because it works, and once you have a working protocol, you're too scared to explore and find out if there are other working protocols. Anybody who's been through it knows what I mean. One last point. I keep talking about exploration as if there's a space of protocols which you can try out and look at and decide, which parts of it you're going to protect. But some protocols are exploratory, that we do one sequence and then we find a completely different sequence. But other protocols are additive, meaning I take my old sequence and I add a little bit to it. I make a small change in it. When you do that, you're not exploring the solution space. And to make it absolutely clear, if you don't know what the solution space looks like, you probably do not have IP that protects the entire solution space, and your competitor could avoid your IP and just choose a different point in the solution space. So why is it so difficult to protect protocols? One reason is that a protocol has multiple steps, and if you imagine a claim that covers the protocol, any one of these steps can probably be avoided or modified. If it's a simple protocol, it can often be applied by people. When we say people, we're talking about your end user. And you usually don't want to sue your end user for two reasons. One, you want him to give you money afterwards and buy product. And two, there's so many of them, it's too expensive to sue. The mechanism behind the protocol usually has a lot of guesswork. And again, that invites design around, because if you don't know what's happening, people can find a different way of doing it. If you do have a sophisticated protocol, which includes feedback, which is adaptive to situations, which is personalized to a user, then obviously it's much more difficult to do a black box reverse engineering. In other words, if I have a pacemaker in my body, whose logic depends on feedback and is adaptive to, let's say, if I'm running or walking or standing, and is personalized to my particular needs, then just by measuring what's happening in my pacemaker doesn't teach you how to do the protocol. And all of these things also mean that if you do processing of part of the protocol in the cloud, you can perhaps protect that using trade secrets. Another big problem with protocols is you're risking mismatch between the scope of the claim and the enablement you have in your application. Okay, you have one example of a protocol or two examples of a protocol, but your claim, of course, is very, very broad. So is the entire scope of the claim enabled? One possible solution is what we call plausibility. If you can show that it's plausible that what you write actually works, and later it's actually shown that it did, in some countries that's enough. It will be considered enablement, but it means that you have to show articles or other logic which convinces you can get from one to the other. Reach through we will talk about in a minute. So I'll go back to my three types of protocols. And the question is, how good is my potential for reach through? If you've listened to the previous talks, you know I like reach through, which is basically trying to get IP not on what you're doing, but beyond that, on what your clients are doing, or what your clients' clients are doing, or what your suppliers are doing. In general, I think treatment has the least potential for reach through. This is, of course, very general and not for any specific situation, especially if there already is an ecosystem for identifying patients. It's kind of difficult to do reach through. If you have unique results or side effects, it could be better. Diagnosis is probably best. because when you do diagnosis, you're at the starting point and everything happens after the diagnosis, and you can reach through to the treatment, to the monitoring, to other ongoing activities. But usually people pay more for being treated than for being diagnosed. So the overall value might be lower. And a communication protocol is intermediate. And the two big issues are, on the one hand, are you creating new abilities in the system because you have the protocol? For example, real-time video. If I invent a protocol for real-time video, maybe I can get a useful patent. But the other problem is, and in software, software architectures designers are in love with abstracting away different layers. So if you're familiar with OSI ISO 7-layer model, each layer is supposed to be agnostic, hopefully, to the one below it, which basically means that you're not getting any reach through. I'd like to compare protocols to 3 different types of IP. We talk about pharma. So in pharma, you have one true way, the drug, and all sorts of adaptations, also in protocols. And what's unlike is that in pharma, you have very high modes of technology, regulatory, testing, and clinical, which means it's more difficult for somebody to design around once you've got there. In protocols, not so much. In biomarkers, what is similar, that if you have one, there could be others. But on the other hand, biomarker is usually closer to what's really happening in the body. And when you talk about the claim, biomarkers usually have a single point of failure, and protocols can have many. And another example is a feature in machine learning. Anybody who has a machine learning system and uses features as a classifier. So what's similar is if you found one feature, there might be others. If you found one protocol, there might be others. Usually you don't have a good idea as to how critical any particular feature is, not of machine learning and not of protocols. And what's different is that software usually gives you many more options for scaling and for reach through. I'm going to compare a little bit more about software protocols as compared to medical, especially treatment protocols. So what happens on day one? On day one, the particular protocol you have might not really be better than any other potential protocol. The medical protocol is treating a patient. The competition is also very different. On day one, there can be multiple different competing protocols, and the one that wins often has to do with who spends more money and has a lock-in on the industry. In medical, there are usually fewer protocols in play at any given time, and how well you actually treat people becomes very important. The type of moat that you create to block competition is very different. In software, protocols act as a type of focal point, and the moat you have is usually some type of network effect, meaning the more people use a protocol, the more people want to use it, or some type of sunk cost. The minute people start using your protocol, changing the protocol is very expensive. Medical treatment, you can build a moat, but it's usually due to things like user preference, regulatory habit. In other words, what is the FDA like? Payer lock-in, there are a lot of conservative bodies, including the ones who pay out money, and a buildup of a body of experience, which is difficult to move over to a new protocol. And last but not least, how do you grow? So software runs on machines, sell more machines, more people use your protocol. Medical protocols usually are applied by humans and often applied in secret. And as we said before, you don't really want to sue them. So what should you be looking for? when somebody comes up with a protocol invention. Most important is to try to understand why the particular protocol works. It will help you match the claim scope with enablement. It will help you understand whether the invention is more on the physiological side, which is less predictable and more scope problems, or more physical. And most important, protocols are used to treat patients. The word treat requires a high level of proof. But in order to get IP, you don't have to treat the patient. You can do some lesser end effect. In other words, if I have a way of preventing people from dying of lung cancer by convincing them not to smoke, it is difficult to get a claim for preventing lung cancer, but much easier to get a claim for reducing the number of cigarettes they're smoking. It's very useful if you can, and the client might object, to define a space of protocol instances and try to define which ones work and which ones don't. And if you can identify different parts of the space, and of course, claims of different scope cover different parts of the space, that's wonderful. You want to identify different inputs, what we call patient selection or context. Protocols which make it more difficult to use existing devices or which require you to use a device in order to apply them, that's very good. You should look for them. Side effects, both negative and positive side effects, give you a way to escape from the pure protocol. Whenever there's a protocol, there will be a learning process in the device, meaning how the protocol is applied. In the company, now that they have a working protocol, things are going to change. And in the entire ecosystem, that's especially true in software. Look at the internet. You should ask yourself whether the protocol will be used alone or together with something else, like a drug or a different protocol, which has different time scales of changing or of affecting. And last but not least, protocols are very conservative because changing them requires a lot of points of change. So you should ask yourself, what is the timeline? We know what the timeline is for the patent publication, but what about for R&D, for results, for understanding of what is critical about it, publication that the client does on the way? And when will other modes, like the one we talked about on previous slide, or gaps, which mean easy ways to design around, come into force? So if we get a protocol patent and it's good until we have a network effect, that's good. If we get a protocol patent and it can be designed around before we get a network effect in place, that's bad. Finally, here's an open question, and there's no good answer. It's open. I don't have an answer either. And the question is, if I have multiple mechanisms to explain my protocol, should I describe them? Why, yes. The more mechanisms I describe, the more I can chain together different inventive ideas and protocol portions and options. I can use mechanisms to explain why I have more scope and why plausibility. And of course, and I've been told this by at least one examiner, you can't both be right. So the more mechanisms you describe, the more risk you have of being wrong in the sense of you haven't taught how to do it. And not but not least, you're helping your competition without clearly getting an improvement in protection. So till now was talking about protocols, and I'd like to tell you half of a story, and you can feel free to supply the other half. The first half is when you pace a heart with a pacemaker, okay, it's an implanted device, it has a battery. If you use too much power in each pace signal, the battery will get used up fast and people will have to get an operation to replace a battery. If you use too little power, maybe the heartbeat won't be captured and then the pacemaker won't do its job and the patient will be sick. Now, imagine the competition has a broad and strong patent that basically says pace with a low power, sense if you didn't capture the heart, that the heart's not feeling the pacing, and then send a stronger pacing signal if needed. Your client is a leading pacemaker manufacturer. What should they do? Okay, both IP and non-IP. And do you have any idea of how much this advice will cost you? And last but not least, what are the risks? Now, this is based on a true story, and I'm only telling you the first half of it. Okay.